So what does a word actually mean? It sounds like such a simple question, doesn't it? But for the scientists who study language, it's a puzzle that has sparked decades of really intense debate. In this explainer, we're going to dig into how the study of meaning went from being just a matter of opinion to a real data-driven science.
I mean, just stop and think about a simple word like run. You can run a race, you can run a company, you can run a fever. A river can run, your nose can run. Heck, you can even run into an old friend at the store. So how many different meanings are we even talking about here? It's this deceptively simple question that really kicks off our entire journey.
All right, so to even start to wrap our heads around this puzzle, we first need to get a grip on two core ideas that linguists use to try and map out this huge territory of meaning.
Okay, first up is a concept called polysemy. This is basically the fancy official term for our whole run problem. You know, when one single word points to a bunch of different but related concepts? Just think of it like this. It's the reason dictionaries have all those numbered entries. 1, 2A, 2B. Yep, that's polysemy right there in action.
And then, on the flip side, you've got synonymy. This is the exact reverse situation. You have multiple different words, like start and begin, that are all pointing to the same basic idea. So you've got one word with tons of meanings and tons of words with one meaning. You can see how this gets really complicated really fast.
So how did linguists originally even try to solve this? Well, for decades, their most powerful tool wasn't some fancy supercomputer or a massive data set. Nope, it was their own intuition.
Yeah, the method was called introspection. An expert would literally just sit and think, using their own deep knowledge of a language to map out all of a word's different meanings. They'd create these super complex diagrams they called radial networks, with the core meaning right in the center and all the related senses branching out like spokes on a wheel. It was basically a map of meaning, drawn entirely from an expert's gut feeling. And this slide right here, wow, it just perfectly illustrates the problem. Just take this simple word over. One famous linguist said it had 21 different senses. Another came along and said, nope, it's 17. Then a third argued there were really only 3. It's the perfect example of the issue. When every expert has a completely different map, which one are you supposed to follow? And this gets right to the heart of the scientific problem. Without a way to actually test these claims against real-world evidence, you can't falsify them. You can't prove anyone wrong. The entire study of meaning was in danger of becoming nothing more than an endless circular argument of opinions. So clearly something had to give. The field needed a major pivot from analyzing what experts thought a word meant to actually observing how real people use it in the real world. And this simple idea, it pretty much sparked a revolution.
This led to what's called the usage-based model. The idea is so simple, but also incredibly profound. A word's meaning isn't just some abstract idea floating around in our heads. A word's meaning is its use. So to understand run, you don't just sit and think about it. You have to go out and analyze every single real-world sentence where people actually use the word run.
And this just completely changed the game. The object of study was no longer some imaginary mental dictionary. It was now concrete, observable, and measurable language. But to measure it, linguists were going to need a whole new set of tools.
This big shift toward a truly scientific approach created a new, non-negotiable requirement. If meaning is found in usage, well, you're going to need to collect and analyze a massive amount of it.
And that is where the corpus comes in. A corpus is a gigantic, organized collection of texts. And I mean gigantic. We're talking millions, sometimes billions of words from books, websites, newspapers, spoken conversations. It's basically a giant snapshot of how a language is actually being used out in the wild.
You can really see the fundamental shift right here. The old introspective method, it started with a theory inside one person's head. The new data-driven method, it starts with a mountain of real-world text and builds the theory from the ground up, based on patterns you can actually see and measure. It's a total move from subjective to objective.
But, you know, it's interesting. Even using a corpus can be done in 2 very different ways. The old way was corpus exemplified, which is basically just cherry-picking a few examples that support an idea you already have. But the truly scientific approach is corpus-driven, where you use all that data to rigorously test and even try to disprove your own hypothesis. That's the real key to discovery. So why is all this so essential? Well, because language is just this impossibly complex system, right? Meaning isn't just in the words itself, it's woven into grammar, context, social cues, all of it.
Our brains, no matter how brilliant, just can't track all those interacting variables at once. But a computer can. It can find the hidden patterns in all that chaos, and, most importantly, it gives us a way to finally, scientifically, test our claims about meaning.
But here's the really cool part. This new data-driven approach didn't just toss out all that old introspective work. Actually, it gave it a new and incredibly vital purpose.
See, this wasn't about rejecting the old ideas. Instead, it was more like a natural evolution. The data-driven approach is really an extension of that early work, not a replacement for it.
And this timeline shows that evolution perfectly. Through the 80s and 90s, linguists developed these fascinating, really complex theories just based on intuition. They had these amazing ideas, but they didn't really have the tools to prove them. Then, in the 2000s, technology finally caught up, giving us the computing power and the massive data sets to put those decades-old theories to the ultimate test.
And this is how it all comes together in this powerful scientific cycle. Those intuitive theories from the past, they aren't thrown away. They become the testable hypotheses for today. Then we use modern data and statistics to test, to refine, and to build on those ideas, making the whole field more rigorous, more objective, and way more powerful.
So we've gone from opinion to observation, from pure introspection to data-driven induction. But this whole journey raises a pretty fascinating final question. If a core component of our humanity, the very meaning we create with language, can actually be mapped and measured with data, what does that tell us about the hidden structure of our own minds?